All right, class, happy Friday. I have not forgotten about you, I promise. I do want to have a quick, just a few minute video on literal equations. This was our new topic that we introduced yesterday, and I'm going to try to be super quick on this for you guys. I just want you to know that literal equations are any equation or formula with at least two variables. And if you see here, these are mathematical equations that literally have no numbers. And so the point of the lesson is basically letting you guys know that no matter if we have a number or a variable, we can still move it around and solve for anything that we want. And yes, we are using mathematical principles to solve for equations and move around technically letters of the alphabet. But letters of the alphabet in math stand for variables. We don't know what they are. That's why it's called a variable. But it follows the same rules as if we were dealing with just numbers. Okay? So these are called literal equations. And we can add, we can subtract, we can multiply, and we can divide variables. Right? And I'm going to show you how in 3 examples. And this is going to be some of the examples that you see on your homework. So about the homework real quick. There have been some questions. It's kind of a 2-part thing. The first part, it's in the Google Classroom right there in one of the most recent posts. There is a PDF. Please click on the PDF. It will pop up 8 questions, 8 blank questions that I want you to solve for. It'll tell you what to solve for. And so after you do those 8, if you do those 8 in your math notebook, on page 2, if you scroll down on that PDF, are the answers to those. So you literally just check your work. You do not have to turn in the PDF. You have your questions and your answers in your math notebook. You check it. And then, so that was the first part. The second part is what you actually turn in. You go to the Google Forms question that I posted right above that in the Google Classroom. And that's when you just answer one thing for me. How many of the 8 did you get correct? 1, 2, 3, 4, 5, 6, 7, or 8. You click submit, and then boom, there's your homework. So the PDF is just for you. You can copy down your work in your math notebook, and then you submit the Google Forms question with the number you got correct, and hand that to me, okay? All right, here we go. Literal equations. Anything with at least 2 variables that we can move. Pretty much from now until the end of the semester, we're going to be dealing with literal equations almost. And so anyway, here we have the ideal gas law. PV equals nRT. That's a real formula. What if we just want to solve for T? All right, when we say solve for T, it's the same thing as getting that T all by itself. All right? Right now, the T is being multiplied by an R and multiplied by an N. All right, and it doesn't matter if it's lowercase or capitalized, it's still just a variable. It doesn't matter if it's upper or lowercase, it still follows the same rules. If we want to solve for that T, well, if it's being multiplied by R, multiplied by N, how do we undo that multiplication? Well, the opposite of multiplication is division. N, R, and what we do to one side, we do to the other. N, R. Boom, just like that, all right? We are literally dividing letters, and that's okay, all right? It follows the same rules that we do with anything else in math, right? Now, the thing is, the reason why we want to get that T by itself, if we divide by an NR, these cancel out, right? And so now we technically have a divided by NR at the bottom right here. Now, these variables, they are not like terms. They are different variables. We cannot combine them in any other way. So just like that, we have our final answer. I'm going to put T into the left, so I'm going to switch to the side right there. T equals, we solved for T. T is all by itself, and whatever we have right here, P, V over N, R. Boom, done. Literally, like no calculations, no numbers. This is what has to do with literal equations, solving for a variable, okay? On Tuesday is when we're actually going to take this and get a little more complicated with it. So I want you guys to get this foundation. All right, second one. Let's just say if we want to solve for x. All right, we want to solve for x. We want to get that x all by itself. Let me check something real quick. What's my time? Okay, perfect. If we want to get that x all by itself, now the other day, yesterday, a lot of you guys were like, oh, we're going to divide by a negative y. we're definitely not going to divide or anything, because right now we have that x, there's a minus y. It's not being connected with like multiplication or anything. It's technically being subtracted, x, and then subtracted by a y. So if we want to get that x all by itself, we undo the subtraction by adding the y. And that's done. Now we can't just leave it like that. The y can't just go away, because then we have a false equation. But once we put it to the other side, then we have our equation back. We're just moving variables around. If we add a y here, we have to add a y over here, z plus y. Now this is, once again, key. Z and y, definitely not like terms. We cannot combine them in any way except for, we just list them out as is. I have my x by itself. That's going to be put down here to the left. Z plus y. And the reason why it's plus y, because I did it to this side, and I have to do it to this side. Quick note, if you did this, z plus y equals x, that is totally fine too. I like having my variables on the left for some reason. That's just me. If you put this on a test, you would not get marked wrong, because it is essentially the same thing. It's just flipped, right? I also gave blood today, guys. Yeah, saved some newborn babies. Okay, last one, then we're done. We're going to solve for y. Here we have BC equals xy. The b and c are being multiplied together. The x and y are being multiplied together. Those are it's kind of similar to our ideal gas law, our very first equation. If we want to get that the y all by itself, well, if there's an x that's being multiplied by it, boom, 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 boom. X's cancel out. I divided over here. Now they're gone, but I still divided over here. My final answer is BC over x, because I divided by the x, equals y all by itself. Boom. All right. Thank you guys so much. I really appreciate it. I hope this helped just a little bit. We're going to be going more in depth on our next lesson. All right. Thank you guys.